using substitution. So there's a word that I've already seen here. What is a system again? Who can tell me what a system of equations is? Multiple. There has to be more than one. All right, and we already learned the method. We could graph them, right? Find the intersection point graphically. This is called using algebra to find the solution. All right, so here's the strategy. I was told in Algebra 1, you've already been shown this. You might not remember it, but this should not be new for anyone in the room. So it's the algebra piece that we need to really practice and buff up. All right, to do substitution, a variable needs to be isolated, which means by itself. In this first equation, see how it says y equals? Well, that y is by itself. What you do is substitution. What is y equal to? 5x minus 7. You circle this 5x minus 7, and we're going to substitute that in for y in the second equation. So I'm just going to draw an arrow to the y value in the other equation. So now I'm going to rewrite the second equation. The idea is if you only have x or you only have y, you can actually solve the equation. I can't solve an equation that has two different variables. All right, so here's the really important part that you write carefully so that you can read your own writing and you don't lose any negative signs or constants. So I'm going to rewrite the second equation, negative 3x minus 2. And then instead of writing the y, I'm going to write parentheses 5x minus 7 in its place. So I substituted that in for the y value, equals, and then I'm going to continue and write the rest of the equation, negative 12. Does that feel familiar at all? Maybe once in a dream you did it in Algebra 1? That's it. You did the hardest part. You just did the substitution. The rest of this is just doing the algebra to solve for x by combining like terms or using the distributive property. So my first step would be to do the distributive property, right? Take this negative 2 and distribute it to both terms in the parentheses. Don't skip any steps. So I'm going to write negative 3x. What's negative 2 times 5x? Negative 10x. What's negative 2 times negative 7? Positive 14 equals negative 12. Does anyone's eye go to, oh, that's the next step? How do I solve this for x? What's my next step? Combine like terms. How many x's do I have? Negative 3x minus 10 more. So I'm 3 steps in the hole, and I'm going to go 10 more steps in the hole. So how many x's do I have? The negative 13 of them plus 14 equals negative 12. All right, next step to solve for x. Not quite. I want to get x by itself. What can I move to the other side of the equation? The 14. Subtract the 14 to the other side of the equation. So negative 13x, and that's equal to, I'm just going to do this in my head, but if you needed to use a calculator, I'm taking negative 12, and I'm subtracting 14 more. So I'm at negative 26. Oh, I lost it. Here we go. What's my last step? What's the opposite of multiplying? Divide both sides of the equation by negative 13, and I solved for x. X must equal 2. You have half of your answer now. Because what's the solution to a system of equations? An intersection point, right? Which is x comma y. I only know the x. How can I use my equations at the top to figure out what y has to be? Does anyone remember how to do it? Yeah. Yep, so you can use either the top or the bottom equation. But if this one is already solved for y equals, the top equation is the one where you want to plug it in. So y has to equal, right? I'm going to plug it in 5 times 2 minus 7. So once you've solved for the first variable, you are going to plug it in and solve for what y has to be. What is 5 times 2 minus 7? 3. So y is equal to 3. And then once you have your x and your y, the best answer is to write it as the coordinate, right? So the coordinate is 2, 3. And if I graphed these lines on an axis, they would intersect at 2, 3. So this is a different strategy that does not involve graphing. So some of you who are really struggling with graphing, you'll be like, well, you know, I got to work on the graphing piece, but I know how to do this. This is algebra that doesn't involve graphing. So it's playing to, you know, what strategy do you like better? All right, so I'm going to do another one. This is a bonus for your quiz tomorrow, and we're going to do like one more for practice. And on your agenda, it says that tonight I'm assigning homework 1-3. So if you're a person that you're strict to that agenda, I'm not going to assign homework 1-3 until Monday. But if you have a very busy week next week, that might be a homework you want to start over the weekend. I do have an optional graphing practice as homework. And for the people that haven't done homework 1-1 yet, or didn't do all of homework 1-1, it's not going to be optional. It'll be your makeup assignment if you want credit for homework 1-1. If you got every question correct on homework 1-1 and you don't feel the need to do extra practice on graphing, then there's like 3 of you that could take a pass on it. But most of you missed a couple questions on homework 1-1, so I would say you probably need to do it to be ready for tomorrow's quiz. Okay, so here we go. I need to isolate, so I need to get one of these variables by itself. This first equation, this y is very close to being by itself. All I have to do is add 4x to the other side. So see how I'm doing that? I'm going to add 4x to the other side. So I'm just going to rewrite this over here, and I'm going to say that in the first equation, y has to equal 4x plus 6, because I'm adding 4x to the other side. Pick whichever one is easiest. If it says 5x plus 3y equals 39, I wouldn't choose the 5x or the 3y. I would skip down and try like this equation. This y is by itself almost. All right, so circle what y is equal to and draw an arrow to where that's going to go in the other equation when you substitute it in. It'll make it easier for you to follow the steps. Now we rewrite that other equation. So negative 5x stays the same. The minus sign is still going to be there, but instead of y, I'm going to write 4x plus 6 in its place. And then equals 21. So the process is the same every time. Now you need to use the distributive property. So I'm going to distribute that negative sign into the parentheses. Negative 5x minus 4x minus 6 equals 21. See if you can combine like terms. If you think you know what you're doing, see if you can do the next step and combine like terms. Look up at the example that we just did. What did we do to combine like terms? Okay, so my like terms are these x's that are sitting right here. I have negative 9 of them. Would you agree? So negative 9x, I still have minus 6 equals 21. What's my next step? Add 6. Add 6. So now I have negative 9x equals 27. I'm getting close to the final answer here. What's my last step to get x by itself? Yep, divide by -9 on both sides of the equation. And if you need a calculator, use it. But do you guys know the rules for nines on your fingers? I've been using that one since I was a kid. So what is this? 9 times 3 is 27. Did you know that if you put that number finger down, so if it's 9 times 3, see we have 2 fingers over here and 7 fingers over here? So what would 9 times 6 be? I put my 6th finger down. I have 5 fingers on this side and 4 fingers on this side, 54. So you can do all the nines on your finger. I don't know why that works, but it's a pretty cool trick for nines. So x is equal to -3 because a positive divided by a negative is still a negative number. That's half of my answer. What do I do to finish this problem? I need to solve for y. Take it back up to the top. Y has to be equal to, see how I circled this guy right here, 4x plus 6? That's where you want to plug it back in, because that's the easy one to plug it back into. 4 times -3 plus 6. So I'm going to take my x value, plug it in for x, and get a y value. This is -12, and I'm adding 6. So I get -6. Some of you, is your mental math skill coming back from after the summer a little bit? If not, use a calculator. Because when you get that far, to make the mental math mistake, that's unfortunate. Use the calculator to check your math. But y would be -6. I should write my final answer as the coordinate -3, -6, x, y. And we're going to see some examples where there's like, oh, there was no solution. Or, oh, there's many solutions. But these were just finding an intersection point algebraically. Okay, so I want you to try one more example on your own. I'm going to show you which one to try, and then we're going to move on to do some review for your quiz. So take a look at page 106, Solving Systems of Equations by Substitution. And I'm going to help you set it up, and then I want to see if you can carry it through and actually get the solution. This one is a little bit different because what variable is isolated this time? Does your brain kind of see that there's an x by itself right here? This y is going to be tricky to get by itself, and so is this x. But in the second equation, do you see how x is already by itself right here? So you're just going to do a different variable this time. You're going to plug this in for x in the top equation. So you pick which one is easiest to get by itself, and we're going to plug it in for x in the top equation. So I'll rewrite the equation for you, and then you're going to try to, this is page 106, you're going to try to combine your like terms, solve for y, solve for x. Okay, I'll give you a couple minutes to try it. Let's rewrite the equation. The 2y stays the same from that top equation. Minus 4 is going to stay the same from the top equation. In place of the x, I'm going to write 2y minus 8. 2y minus 8. And then I'm going to finish that top equation with equals -4. And then I'm going to take it away. See if I can use the distributive property, combine like terms, and solve for y. Because on the quiz tomorrow, there's a bonus. You might as well at least take a stab at it tomorrow, because next Friday, it'll be on that quiz with solving by substitution. So it's like a freebie to try, and then, you know, on the next quiz, we'll be practicing it all week next week. You'll be able to try it. So see if you can get there. I'll put my answer up in just a couple minutes. And here is the answer to that practice problem.